Hi, it's Naomi again. I'm going to graph this system of inequalities. So here we have 4 inequalities. We want to graph them all and see where they overlap on the grid over here, the coordinate grid. And these first 2 are given to me in standard form. So for standard form, my preference is to graph using the x and y intercepts, which of course I just substitute for x, 0 for x to find y, and then 0 for y to find x. So the y-intercept, I let x be 0, and then I'd have 3y equal to 9. And if 3 times something is equal to 9, that something is 3. 3 times 3 is 9. So that's going to be one of my points. Now the second point, I'm going to let the y part be 0, and I have to find the x part. So the y part would make this term 0, and I just have x equals 9. So my second point would be 9, 0. So if I were to graph these 2 points, the first one is 0, 3. That's over 0 up 3 right there. The second point is 9, 0, so that's over 9 up 0. And then the graph should look something like this. Now, of course, this is an inequality and not an equation. So I'm going to have to shade in one direction. And I decide which direction to shade by substituting in a point. And normally I substitute in 0, 0 if I can manage it. So I can't substitute a point on the line, but I can substitute any point off the line. 0, 0 is an easy point to work with, so that's what I tend to work with. Now if I put 0, 0 in here, I'm just going to do it in my head. So 0 plus 0 is less than or equal to 9. Well, that's something that's true. 0 is less than or equal to 9. So I'm going to shade this entire side of that line. That's what it would look like. It would just shade this whole side here. Now, since I'm really only looking where the inequalities overlap, I'm going to erase it for now and come back. But I need to remember I'd shade down for this first one. The second one works exactly the same way. Only here, when I put 0 in for x, I'm going to get y equals 9. And when I put 0 in for y, I'm going to get x equals 3. So 3x equals 9, x is going to have to be 3. And so you can see my points are just kind of reversed here. So if I graph a line, 0, 9 is right here. 0, 3 is right there. And again, if I put in 0, 0, it would make this inequality true as well. So I'd shade down on this one as well. Just this one would look like that when I shade it. But you can see the 2 overlapping would be right here at this point. We still have 2 more inequalities to take into consideration. So x is greater than or equal to 0. This one, it's like x equals 0, and x equals 0, anytime we have x equals a number, we know that that is going to be a vertical line, because we had all these vertical line graphing things a while ago. So when I graph that line, it's just the y-axis where x equals 0. So it looks like that. And, well, that's a little off. Looks like that. And when I shade it, I want x values that are greater than 0. So if we look over here, we know these are the x values that are less than 0, -9, -5, -2, those are all less than 0. Over here on the right, these are the x values that are greater than 0. So if I were just shading for this one inequality, x is greater than or equal to 0, it would look like that. Now, since I'm not, I'm shading for all 3. Right now I'm in this part. I also have to worry about this last one. Okay, so for the very last inequality, that's y is greater than or equal to 0. I know y equals 0 is going to be a horizontal line for the same reason that x is equal to 1 is a vertical line. So if y is equal to 0, the height is always 0. All these points make the height 0. So that's y equals 0, and then x can be anything. But greater than 0 would be shading up. So if I just wanted to do that one inequality, I'd have to shade all these parts. But I'm not worried about just that one inequality. I'm worried about all of them. So I need to shade where they all overlap. And I could test a point here like 1, 1 or 2, 2. Make sure it makes all of them true. It would. And then that would just verify for me to know that I'm right. Okay, I hope this helps. Bye.